Hi everybody and welcome back to FAANGForge. Let's dive into another Leetcode problem. Today we're solving Leetcode number 56, merge intervals. So given an array of intervals where intervals of I is equal to start of I and end of I, we want to merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. That was kind of a crazy way to write that. They said intervals like way too many times, but you kind of get the point. Basically, in this example, number one, we have this list of intervals, and we start off by saying 1 and 3 and 2 to 6 overlap. So we combine them into 1, 6, and then 8 and 10 and 15 and 18 don't overlap with anything, so we just add them to the output as they were, and that's going to be our output. And we see in this explanation, they say, since intervals 1 and 3 and 2 and 6 overlap, merge them into 1, 6. So how do we want to solve this problem? Well, if you're like me, you might pretty quickly be able to see that, hey, we know if two intervals are overlapping, if the ending element of one interval is going to be greater than or equal to the starting element of the interval after it. So in this case, we know we have 1, 3, and 3 is greater than or equal to 2, so they're going to be overlapping, and then we need to merge them. That's kind of where I was able to get to. After that, I thought I was going to be flying through this problem, but I had a little bit of a issue because I didn't quite realize that there's an edge case you need to watch out for. And that edge case is actually going to be if the interval you have is going to be completely larger than the interval after it. And you'll also notice one more edge case that's kind of even more important. There's no guarantee that this list of intervals is going to be sorted. So you could end up trying to follow this intuition and you'll correctly merge the intervals that are right next to each other, but it's not necessarily the case that they're going to all be in sorted order, so you would miss out on merging some possible elements. So, of course, the first thing you want to do, and it's kind of unfortunate from a time complexity standpoint, but you're going to want to sort the list of intervals. Once you've sorted the list of intervals, you then need to proceed through and consider that edge case. That edge case where you know you have two lists that are possibly overlapping, but you need to consider not just merging them willy-nilly. Like in this case, you wouldn't just say 1, 3, and 2, 6 overlap. I'm just going to make 1, 6. In this case, that is correct, but it won't always be. And let's run through an example to make that clearer. So let's say we have 1, 8, and then the next interval after that, once I've sorted, of course, is going to be like 2, 5. Well, right here, I'll compare 8 to 2 and see that 8 is bigger than 2, but I can't just merge 1 to 5. That will actually give me the wrong interval that I'm going to add to an overall output list. That would give me 1, 5, and that's smaller than the range we need to create, and that range is already existing in 1, 8 itself. So once you decide that there's an overlap, you need to not only merge them, but merge them such that you take the greatest value from both the outer bounds of the left list and the right list. So that's the intuition behind this problem. Let's dive into the code. I think it'll make a lot of sense. So as I mentioned before, we're going to have an output list. I'll just call that merged. And then we want to sort our intervals. So I'll do intervals.sort. And in Python, when you're sorting a list of integers, it sorts them based on the first value. So it would sort them like this, and then it breaks ties in the case that the first values match by using the next value in the list. Great, so this will sort it exactly how we want it to. And then we will loop through every interval. So we'll say for interval in intervals, and we want to check if we have anything in our merged list. So if we do have an element in our merged list, that's great. We're going to say if merged, and the element at the top of merged, which we can get by doing -1 in Python. This is the last element in the merged list. So if the most recently merged element's ending bound, which is going to be the first index, is greater than or equal to the currently being considered interval's starting bound, then we know we have an overlap. So in that case, we'll just set merged of -1 equal to merged of, or actually, let's see. We just need to update the last bound. So I'll say merged of -1 of 1. So the most recently merged element's ending bound should be the max of merged of -1, 1, whatever it currently is, and interval of 1 to properly expand the range once we've merged them together as far as we can. Great. Now, otherwise, if we don't have anything in merged, then of course we need to append an element, the current interval, to merged. And if we do have something in merged, but they don't overlap, which we can verify from this statement, then we also need to just add that element to merged. Great. So those are going to be our two cases. Once we've finished applying this intuition throughout intervals, all we need to do is return merged. Great, so that's going to be our solution. Let's run through an example. Let's start with here. We have 1, 4 and 4, 5, and this is going to be equal to intervals. Great, and we'll have our merged list like so. And we would sort this one, but this one's already sorted, and it's kind of a tricky problem because in the examples, they don't show you any inputs that are not already sorted. It's just something you have to pick up on, probably from asking clarifying questions to your interviewer, that the list won't always be in this nice sorted order. So you do need to sort it. Great, but let's imagine this was unsorted. We sorted it. Great, it's 1, 4, 4, 5. Now we're going to start looping through all the intervals. First off, do we have anything in merged? We don't, so we immediately go to our if statement and, our else statement, and we append to merged the current interval, which is 1, 4. Now we loop again. When we loop again, we're now looking at 4 and 5 as the current intervals, and we'll say, is there anything in merged? Well, there is, but is merged of -1, which is going to be the top of our merged list, the last element, is merged of -1's outer bound, which is 4, greater than or equal to interval of 0, which is going to be 4 in this case. Well, it's actually equal to it, so that's great. We need to merge them. So how do we merge them? Well, we just set merged of -1, which is again 1, 4. We said that's outer bound equal to the max of 4 or 5. Cool, so 5 is bigger, so we update this to be a 5. And then we continue and we see that we've actually exhausted all the elements in the intervals and we're done with our computation and we just return merged, which is going to be 1, 5 in this case. Great, so that's an example. You can kind of see how it works. Run through a couple examples yourself if it doesn't make sense. I think it'll be a really awesome problem to be able to figure out that way. But yeah, I hope that this helped. Let's run through the time and space complexity. Well, we are first right off the bat sorting the list. And in Python, sorting a list has a big O of n log n time complexity, where n is the length of the input list that is being sorted. In our case, if we define n to be the number of intervals inside of intervals, then we are sorting, n log n elements, and thus we have a big O of n log n time complexity for this operation. Otherwise, we are looping through all the intervals, and we already defined that to be n, so this part of the operation is a big O of n operation. We're looping n times, and all of the computations inside each iteration are constant time big O of 1 operations, so they don't give us a greater time complexity than just big O of n here. Now, if we add those together, we'll get a big O of n plus n log n time complexity, but asymptotically, as they both grow, n log n grows far faster than n does. So we simplify the time complexity to be equal to big O of n log n, where n is the length of the input list intervals. Now, what about space complexity? Well, space complexity is pretty similar. If we're considering the output merged as part of our space complexity, then we could merge all the elements, in the worst case, we would not merge any of the elements. They would all be separate from each other and not overlap, so we would have n elements inside of merged. So that would be a big O of n space complexity. But we also sort, and this depends on the language you're coding in, but make sure to mention this in an interview. You want to mention the space complexity of the sort. In Python uses timsort, which is an in-place sorting, but in the worst case, it can use a big O of n space complexity. So this depends on your language, but I would say in Python, this is going to be a big O of n space complexity. And also, if you're considering the output merged, it's also a big O of n space complexity. So that is the solution. Let me submit this. Great. Okay, yeah, we got a pretty good time complexity. This is a wonderful solution. If you have any questions or you solved it differently, Let me know in the comments below. Make sure to like and subscribe and tune in next time. Best of luck.